Good evening, everyone. Am I audible?
Yes, ma'am.
Okay, then let's start. Is my screen visible?
Yes, it is.
Okay. So today's session is like week 3 concept summary. So we'll go through the concepts covered in week 3, starting with what is program. Normally, the program is like algorithm and data structure combined together. We get program. So there are two types of programming style. One is structured programming and other is object oriented programming. So in structured programming, the focus is mainly given on the algorithms first. We will find the algorithms or methods, and then we'll try to understand the data on which we have to apply the algorithms. So in structured programming, we'll divide that particular problem into subproblems like functions and develop the methods or algorithms, and then we'll build into the complex systems. After that only we'll see how we have to store the data into data structures, and everything will be taken into consideration after developing the algorithms. So that is structured programming. Next comes the object oriented design. In object oriented programming, it is the reverse of this particular process. Here the data will be taken into consideration first. We'll focus on the data, and or we can say the object, and after that we'll try to identify the algorithms that to be operated on the data. So we know we have already deal with the Java programs. Here we always create a class. In that we'll have some instance variables, and then we will have some methods which will manipulate the data. So that is object oriented programming approach. An example for a structured programming, okay, is like when we have to prepare tea. What we'll do, we will follow some certain steps first. That is the algorithm. Like we will take the water and boil, and then we have to add the tea powder, then comes sugar, then comes milk. So these steps of instruction, which is the algorithm, this will be given priority first, and then only we will go for the data. And in the case of object oriented programming, an example is, here we have to, if we have to develop a web browser which will contain like 2000 procedures or methods, then what we will do is make some 100 classes, and each of these classes will contain like 20 different methods, and so that these 100 classes will completely contain 2000 procedures. So one advantage of doing this is, if we have to manipulate something, if we something is wrong in some methods, then we just have to look that particular class or object, and we can change that method, so that maintenance is easy when it comes to object oriented programming. And this is one very good example for object oriented design. So here, if you are going to develop an order processing system, so for example like Flipkart or Amazon, you might have seen in the interface the items are listed down, and then orders in account page will see orders, and shipping address will provide, and payment, uh, so some dashboard has to be open after for paying, and then comes the accounts. So what we do is, these are all the tasks that we have to do, and these objects will be first defined, means the classes will be defined first, and after that in items, we will have some operation like we have to add select one item and add to the orders. So there comes the method. And in terms of orders, we will after ordering it has to be shipped, and sometimes we will cancel. So canceling and shipping, these methods will come after that. And then comes in payment object, either the payment will get accepted or it will get rejected. So anything will happen. So these are the methods that comes later. We will define these methods into these objects. Is it okay? Anyone? Anyone please reply.
Yes, ma'am, it's okay.
Okay. So let me continue. So order processing system, we have these objects and these are some of the methods. Next. Next, we have to learn some terms related to this, okay? Behavior, state, identity. These are actually, we have learned everything, just we have to match them. So consider this particular class animal here. So in class animal, we have legs as the variable, and here we have a method run. So this legs, this we can, after creating an object of animal, we can set the legs value as anything like 3 or something. So after creating the object, we are setting the value of that object. So we are giving some information to the this legs. So that is actually the state of that particular object. Then we have this function, sorry, method run. Uh, okay, now it's like simply printing out running. But sometimes we can also, that setter method, right? So setter method may be setting the value of legs as some value. So behavior is changed. Behavior is changed by the setter method. So state and behavior comes there, and then comes the identity. Identity means when we create different objects, each will have its own address or reference. Each of us have our own home, we have our own address, right? The same way each object will have its own feature in order to distinguish from other objects. So that is identity. These are all some terms that we have to remember. And the next thing you have to think is, here the state will affect the behavior that we already saw. And one example here is, cannot add an item to an order that has been shipped. So if we order and that order is shipped, after that if we try to again add an item, we can't do that. So we can tell that item and order, they are interacting with each other, they are related. And another thing is, we cannot ship an empty order. Okay. And next is some relationship between classes. So here we have three different terms to learn. One is dependence, next is aggregation, and inheritance. See, dependence. In dependence, what happens is, if we have a class A and if we have a class B, if if B is depending on A for something, then we can tell class B is dependent on class A. For example, here we have order and account. Order, when we order something, it has to check the account to check credit status. So that is one dependence. Order class is now depending on account class. So and another term we have to remember is coupling. So when there is a dependence between classes, if one class is depending on other, then we can call it as coupling. We have like tight coupling. So when one is completely dependent on other, so that is dependence. And here we have an example that is not dependence. Item does not depend on account. They don't have direct depending that relation. Is it okay?
Can you
Coupling.
give
What
an
is the meaning
example
of coupling?
of dependence?
Coupling means that dependency. Same. One is depending on other. That term is known as coupling. So the thing is, whenever we develop an application or anything, we have to reduce these dependencies. It's not good
What
to
do you
have
refer by the tight coupling? Tight coupling.
tight coupling means it's completely like depending on other. We should always focus on loose coupling. Means each class should be independent of each other. Like it's the best practice.
See, if you go for something slightly advanced Java J2EE, this will be abundantly clear. There will be this concept called dependency injection.
Injection,
That's something
yeah.
which, that will come into play. At this point of time, dependency, we can just, or I'm sorry to interrupt. At this point, we can just think that dependency means these two classes should not be heavily dependent on each other. They should be independent.
Yeah, it is better to to reduce the dependency, but every time there will be dependence. That dependency injection in Spring and all, they will do automatic dependency. So we as programmers don't need to do much. So it will reduce the job of programmers. Don't think much about that now. Some may feel bad.
Okay, ma'am. Okay,
Oh.
ma'am.
So yeah, next is aggregation. In aggregation, if you have a class and that class is using the object of another class, then it is aggregation. It's like an associative relation. Okay. And next is inheritance. We'll discuss inheritance in detailed manner. Anyway, you just see this example. We have express order, which is inheriting from order. So order is the main class or parent class, and express order is the subclass or child class. So one is inheriting from another class. Okay.
Okay, ma'am. Right.
Okay.
One thing, ma'am.
Yeah.
Go to the previous slide. On the encapsulation.
Encapsulation.
Before this. Encapsulation. Yeah, here.
Where is encapsulation?
Encapsulation. Just before this.
Yeah.
Encapsulation. Encapsulation is maintained in a program. What does it mean? Encapsulation is maintained. What does it mean?
It means like data and methods, everything is togetherly bind into a single object. They are like, the simple example is we have tablet, right? So that medicine will be inside that. So it's like protected from outside forces, like nothing will affect. It is completely protected.
Okay. Thank you.
Does it have to do anything with the fact that the instance variables are private and methods are public? Even is that a requirement? Because there's one question in one of the AQs which says, has this been encapsulation has been maintained or not? I mean, I was not very sure how to read that.
Yeah. It is 3.46. I was confusing with that.
Yeah, 3.4Q6.
But there such type of things is not there. We will discuss it later. No problem.
Okay. After going through the concepts, we'll discuss that.
Yeah, ma'am. Thank you.
Okay. So we'll go to next thing. Here, see. Actually, this is like an introduction to inheritance. So first, we'll go through one class, employee class. After that, we will see the manager class, and yeah. So starting from employee class, we have an employee class here. So it has two variables, string name and double salary. And here we have defined some constructors and some mutator methods. In order to set the name and set salary, and then some accessor methods in order to access the name and salary variables. And again, we have defined one bonus method in order to find bonus. So this is about the employee class. And next we will see. So in a company, there will be many employees and some of the employees will become manager. So these managers will have some additional features which is not present in every employees. this manager may have a secretary, a personal secretary. So now we are creating a manager class which is extending from employee. This extends keyword is used to inherit every properties and behavior, every methods and these variables from the parent class, so that now class manager will get everything from employee class, all these things. So as manager is also an employee, he got everything which is mandatory for an employee. And next, the additional features of employee, which is the secretary, we gave here another string. And to set that, set secretary and get secretary method. So what I want to tell is, here employee is the parent class, super class, and manager is the subclass. And this manager is inheriting and all those variables and methods from the employee class. And this is inheritance. And one more thing here we have to see is, in employee class we declared the name and salary as private. So when we declare anything as private, like variables as private, these private variables cannot be accessed even from subclass. Even if we create the subclass, we cannot access the private variables of the parent class. So we have some other techniques in order to access those. One is super keyword. So see here, super of n of s. So here in manager we are going to we are again defining one constructor, and this constructor is taking name and salary variable, but these two are in employee class. So in order to set the value of name and salary, we are using the keyword super. So using super n comma s, this particular statement will invoke the constructor of the employee class. So this name and salary will be set. So that problem is solved. So we access the private variable of the parent class. And secretary is fine because it's manager's
This
variable.
is public. This is public, no, ma'am. N and S is the public employee.
I'm talking about this variable. See, here we have private string name, private double salary. So in order to set that,
But here we are using N and S, no?
that's
Super
okay.
NS.
That is just variable name, right? The values will
Okay.
be now set there.
Okay. Yeah, got
Okay,
it.
clear now?
Yeah, actually.
Okay. So that is
Ma'am?
about it. Yeah.
What if method are private?
Sorry.
In parent class, what if methods are private?
If methods are private, we can't override in subclass. We can use that method, but we cannot override. This overriding concept will come later, so you can understand, okay?
Okay.
And access
in child
modifiers
class, we
will be
can
discussed.
access.
Oh,
So from child class, we can still access if it is private.
hi, yeah.
Okay.
Ma'am, I have one small doubt. Like when we
Yes.
are, hello, am I audible?
Yes.
Yes. So when we are already declaring this as private, then why we are trying to call this in using super? If you want to use super, then we can declare it as public, right?
Actually, like someone discussed about encapsulation, right? So
Mhm.
in order to
Yeah.
protect that data, we are making it private.
No, see,
You can just make public.
if you make it public, then you can access it from any class. Here, you can use the super method to only access from a subclass. So basically, you are restricting it to the class and the subclass only. You're not opening it up. But when you say public, it's open to everything, right? Think of
Yes.
large software kind of packages where you have to develop many modules. In the small things we do, we may not see the big benefit, but in large, software packages and programs, all this will play a big role.
Correct. Yes.
Okay, okay. Could you please explain once this how we are calling super method once again?
Yeah. If you want to see one program, I'll show that.
Yeah, ma'am, it will be fine by program. Yes.
Okay, here, but some more concepts are covered. Mm, but still, this will work. Rest of the code where you are confusing, just leave it for now. I will discuss just after 5 minutes. See here. Here, the first one, line number 46. Is it clear completely, like code? I can't.
Yeah.
Yes,
zoom
yes.
in, zoom in. Okay. Here in 46th line, we are creating an employee, normal object of an employee, and we are passing John and the salary. And here you are you are already seen that bonus function, right? Bonus method. So accessing that bonus method, so we got this bonus as for 10,000. We got the output as sorry, this is 1 lakh. So the bonus is 10,000, and this is where the inheritance. So here, sorry, here again I have to say, wait,
How this bonus came 10,000, ma'am?
and that is equation like into 0.1, salary into 0.1,
Okay.
10% of
Okay.
that particular.
Okay. In the method, it is given,
Yeah,
right?
yeah. Just for now, okay, I will explain that. No issues. Now you want to see this, right? Manager. Okay, see here in manager, this constructor, public manager, string name, double salary, string secretary. So super of name, comma salary. Here, after passing this name and salary, it is not directly setting the name and salary of employee class. What happens is here we are calling name and salary of super class, which is employee class, and it will go here and set our variable. It's like think like that, but we manager got this name and salary attributes, I mean variables. So this is the way how it is invoked. We will call super of name comma salary, so that this will invoke the constructor of employee class, this particular constructor. Okay, and where is string secretary is.
Why can't we make this constructor here only? Manager already public manager class is a class and manager is a constructor. Then we can write this dot name is equal to name.
No, because first I told now it is private. The variables we declared is private. So
No, I'm not going to that. Come to the manager class.
yeah.
Why we are using this super? Can't we use this name is equal to name and this salary is equal to salary and this secretary is equal to secretary?
No.
Can't we use?
No.
Why not?
Because it is private in employee class, and we are deriving those variables from the employee class to the manager now.
Suppose I don't want to use the employee class directly. We cannot use this manager class.
Then no issues. Like we are now learning inheritance, right? So this inheritance now you will feel like it's void, like, but when it comes to bigger programs, we don't have to create the code again and again. We can reuse the same code. For example, here we are now just creating a class manager which is extending from employee, but in a company there will be not just manager. Yeah.
My question is whether we can use here or not. That is strategically we will not use, but it will work or not. What
It will
I'm
not
telling.
work. It will not work. we can't access directly since it is declared as private. Okay.
But
No,
ma'am,
no,
we
I
can
don't want to access that name and salary. I want to create managers name, manager, salary, manager, secretary separately in a
Then
separate class.
yeah, that is fine.
Okay.
But
If
now
you
we are
want to
learning
do that,
inheritance.
why you want to inherit then? If you
Sir?
want to everything separately, what is the point of inheriting them?
Huh.
Yeah, no, that's the thing, right? If like there are dependencies between classes because one is, you know, the subtype of the other. So, I mean, that way then everything can be independent and there will be a lot of conflict. You know, there will be a manager who will not be an employee. All that kind of things can happen, right? Later. So you shouldn't do it that way. That's my point. I mean, that's what I think.
Yeah,
It's okay, right?
whenever you do inheritance, there must be some coupling. So you cannot avoid it completely. So that's why we do not say it's a zero coupling, we say minimum coupling, right? So that's also true. Because if I want to avoid completely the inheritance, we'll lose the code reusability, right? So that is also an important property.
But not just that. My question is, uh, because there is relationship, because if he's a manager, he's also an employee. You know,
Yeah,
it could be
as far
something
as
else.
the object orientation methodology also, it's true that it should be related. Yeah.
And it should be written this way, right? Otherwise, I'll probably create later on I'll create a manager who's not related to the employers. All kinds of things can happen, right? So that could be a problem
The
later.
design also fails. Yeah, I got your point.
Oh, thanks.
Okay. So okay, here we are trying to make, see this particular line, employee E is equal to new manager. Here we are trying to make the type E is of employee, but the object that we are initializing is of type manager. We can do this because every employee is a manager. So even if we declare E as type of employee, we can create an object of manager. But the opposite will not work. We can't do manager M is equal to new employee because every manager, sorry, did I tell the wrong thing? Here it's like every manager is an employee. That's why we are able to do this. But the opposite will not work because every employee is not a manager. And
Right.
yeah.
What is the use of doing this way, ma'am?
Use okay, here see
Why we are
employee.
declaring here this way?
Okay. See this particular array, employee array, new manager. Here, what we can do is in this particular array, we can either take employee object or manager object. So that is one advantage.
For example, like when we are calling manager object, then we can declare with the help of manager, right? Then why we are declaring with employee?
Actually, we'll learn polymorphism so help into that polymorphism. So we'll learn that.
Okay.
Right. So this will be required whenever we go for it.
Yeah.
Okay. Please continue.
This particular thing, just remember this every time. We can always create an object of subtype subclass with a reference from superclass. So this is like a conclusion.
Go back one slide. Just go back one slide, man. But yeah, here. So this we are creating the employee using the manager because manager is a subtype. It will have more variables. But there was this one statement in the lecture which sir said, the object of the child class can be created by taking reference from parent class. No, that's different. I think that's that super method. I don't know. There was some statement.
I'll discuss it later.
Okay.
Hold the question for some time. I'll discuss it later.
Sure.
Okay.
Thank you.
Okay. I'll go for it.
So next topic is dynamic dispatch. Inheritance is over. Is it clear? Inheritance. In conclusion, we can tell that we can create a class from a parent class. So the class that we created is subclass, and the class from which we created is a superclass. So that's about inheritance, and we'll get every property and behavior of the parent class into the subclass. Now, in dynamic dispatch, I will explain this with an example. See this example. Here we have a class employee and two variables, name and salary, as private, and we have a constructor employee. It's taking name and salary and setting the value of name and salary. And then we have a bonus method. This will find the bonus and return that value. And these are some getters and setters. Access, as you have learned, mutators and the other word accesses. So these will set the value and will get the values. And next, from line number 24, here we are creating a class manager which is extending from employee, and manager has this particular variable string secretary, and here the constructor is taking the values name, salary, and secretary, and here we are calling the constructor of the superclass and then setting the value of secretary. And then here again we have the method bonus, and this bonus is different from this particular bonus method. Okay, and get and set method. And in the main, what happens is, first I'm trying to create one object of employee, simply creating an object and passing these values John and salary, and trying to print the bonus, and we are getting the output as this particular output. So this is like simply creating the object of employee and printing the value of bonus. So that is common. And see here, from here we are creating employee E2, and the object is manager, what we have discussed just now, and we are passing the values name, salary, and the secretary name. And first we'll try this particular, see here in the code for manager we have a method called get secretary, and this is specific to manager, which is not present in the employee class. So remember that. So if we try to call the method set secretary or get secretary using E2, this particular code will not execute because E2 is of type employee and set secretary is in manager. So during compilation, what happens is E2, as E2 is a type of employee, it will search whether employee has this particular method set secretary, which is not present. Therefore, it will generate a compilation error. Okay. And then what we can do is, in order to access this particular method set secretary, first we have to typecast this particular employee E2 into manager. Employee E2 is of type employee. Now we are sorry. Now we are typecasting E2 into manager type, and now we have M1, which is actually E2. So Now we can access this particular method set secretary which is present in manager class.
So E2 will access only functions from employee class, not manager class.
Yeah, if we don't, before typecasting, it will access only the methods of employee class. But see, why
But
that
it's
happens?
calling a constructor from manager class, right? With
Yes, yes.
3 parameters.
Inside constructor, it will call the parent class constructor here. Okay. And
Pardon, ma'am. What you are telling inside the manager class? Constructor. Yeah.
this particular constructor. I mean, this super keyword will go and call the constructor from the employee class. Okay. And okay, so set secretary is as it is not present in E2. That's why we got an error here. But after typecasting, it's fine. But I already told set secretary is specific to manager. That's why it happened. But in the case of bonus, if we just, I think these all are clear. Now going to bonus. Bonus method is present in both the employee class here and the same is present in manager class. Okay, so when we try to access the bonus method using the same E2, it will invoke the bonus of this particular class manager. This method will be invoked. This is dynamic dispatch. I will explain once again. See here, employee E2 is equal to new manager, and bonus method is present in both employee class and manager class. So in compilation time, when E2.bonus, when it reaches here, it will check whether bonus is present in employee type. Yes, it is present in employee class. So compilation is done successfully. And during runtime, what happens is, even though E2 is now reference of employee, during runtime, the allocation will be, the memory allocation, the object creation will be of manager type. So now E2 will have, that object will have the methods, this method, this bonus method. Imagine like that. So this method will be invoked when we call E2.bonus. Is it clear?
Ma'am, dynamic dispatch here is coming into play only because both the bonus methods have the same signature as in overriding.
Yes.
That's the only reason why, but is secretary, because secretary is only present in manager and there's no overriding in that case.
No.
So, okay, only when the signatures are the same does dynamic dispatch come into play. And if the signatures were different, then it's overloading.
Overloading comes in a single class, right?
If the signatures were the same, if there were two bonus, if employee had a bonus and manager had a bonus, but the signatures were different,
then
that would be overloading. You're right.
Manager will
You're
be
right. That's overloading.
And then what would happen? Which one would be?
I don't know. I think. Let's say overloading.
What is the question?
If the signatures are different, right? Whatever based on the parameters or signatures given, that shouldn't that method be invoked?
Just because.
Yeah, but provided they are part of the same class, it won't work across classes.
Okay.
Actually, yeah.
So actually, it's a good question. If you can clarify.
Yeah.
Can you tell me just slowly, little bit? I didn't get it.
Yeah. So yes, sir. The question is overloading. If let's say I have a class, don't ask why, but let's say I have a class which has two methods given the same name, right? Let's say I'm calculating the area. There are two methods, both are called area. In one, both the signatures are different. Let's say one is square and one is rectangle. In square, I just need one side. In this thing, I need both left and breadth, right?
Okay.
In this case, depending on what signature or what I am calling, which method I am calling, at the runtime, it will take the decision based on the parameters and invoke the right method, right? But this works only if it is of the same class, right? It can't be like I can't have or I can have different names, same name for different classes also.
I got it. Got it. Let this be over. I'll show the example. That will be easier. Okay. I got your question. I'll come back to that later.
Okay. Okay, so dynamic dispatch is clear in this example.
If we typecast it M1 to manager, and if we call M1.bonus, it will work the same way, right?
Yeah, it will work the same way. The second method will be invoked.
It's okay.
Then it has no any difference, right? Okay.
Yep.
Ma'am, here dynamic dispatch is indicated only at the E2 object, because E2 is defined as the manager. That is why E2.bonus is taking the bonus of the second manager class.
Yes.
Is it so?
E2 is actually creating the object manager.
Yeah.
Even though E2 is a type of employee class, now the initialization is of manager class. That's why.
Yeah. That is why E2.bonus is taking bonus method from the manager class. Is it so?
Yes.
Okay, fine. Okay.
But E2 cannot access any other methods from manager class.
No, not directly.
Not directly.
Madam, E2 is a manager object or an employee object?
Actually, it's the type references of employee, but after creation, it's like a manager object.
Ma'am, what does that mean actually when we are creating object of manager class and it is referring to the employee class? How it is related and what does that mean actually?
Yeah, why we are using this? Why not we are using manager M1 is equal to new manager? It will be simple.
So, yeah.
See, in advanced applications, right, there will be times when you will be needed to create a child class and then have super class access that. So it's in the real world, it is possible. There are scenarios where this has happened. So
yeah, it's according to the program, like problem statement.
Okay. In future, we will use that, right? That's why we are learning.
When you go into this industrial level programming,
because we are beginners, so we are not using it. After that, we will be using it. Okay.
We are
fine.
Trying to understand the concepts first.
Okay.
But what is its meaning actually? I'm not understanding that one. And we are calling this way. And what we are understanding from this? Like we are creating object of manager class, but storing in the class of employee.
Actually, so you know that object creation is done at runtime. So memory allocate. So for example, we have a .java file, and this .java file will go to the compiler. Java compiler will check all the syntax thing and all. And after that, we get the .class file. So JVM will take this, and it's the duty of, so when after compilation also, the memory allocation will not be done for objects and all. So JVM is the one who is responsible for allocating the memory, creating the objects and all. So when I said that, employee E2 equal to new manager, this particular thing, employee E2, this is like static checking, compile time checking. So everything is fine here. After JVM is the one who is responsible for creating this object, new manager. So this is like just a pointer. E2 is just a pointer pointing to somewhere. And after that, this manager, when this manager object is created in the memory by the JVM, then this manager object will have all the attributes, methods and variables and all. Now E2 is pointing to this particular object. So when we say reference, it means it has nothing, nothing but just a pointer to a particular memory area. And then after that, the original memory or the object is created. Now is it fine?
And ma'am, when we write this one as employee E2, what does that mean? Since we created this object and this E2 is referring to this object, and when we write employee E2, then what is that meaning of that
It
employee
simply
E2?
means we have like int A, right? Int A, which means A is of type int.
Means it will have all the variable and methods of employee class, right? That is what it means.
Yeah, basically you're creating an object of employee class.
Here.
E is an object of class employee.
But we are creating object of manager class, right? Here.
Yeah. Here it is just a reference, creating a reference. So it's like expecting some employee class will come here, but later manager came.
Okay, okay.
Okay.
Ma'am, may I say something here? In the class file, after compilation from the Java file, we are having a code, and
Yes.
JVM is executing that code using these runtime environments. So can we say that these all exercises of creating this reference is to save the memory or a stack use of memory? So that because if you create all the class objects, then it will when conversion from the Java file to class file, it will take more memory. That is why the whole exercise, is it so or not?
No.
Okay.
No.
Okay.
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 Okay. So what we have discussed for, okay, this dynamic dispatch itself is called as inheritance polymorphism or runtime polymorphism. Polymorphism will be discussed later in the weeks. Now just remember that. Typecasting we have already discussed, right?
Yeah.
Converting one type into another. And see
reflection.
this particular method, okay? Yeah, reflection. So here, instance of method. Try to remember this method instance of. This instance of method will take one object and it will check whether that is an object of the given class. See here, manager. This is the object. It is checking whether E object is type. Whether E is an object of manager. Instance of means checking whether it is of type manager. So if it is true, if it is true, it will return true. If it is object, it will return true. Okay.
Instance of is a method or is an operator?
It's a method. Operator.
Already defined in the built-in class.
Yes.
Okay.
It's an operator or method.
Okay.
I will tell you later. Okay.
Okay.
And with functionality, you understood, right? It will check whether it is an object.
Yeah, functionality I understand, but how this instance of where it is coming? So I don't.
Abstraction. There comes abstraction. We are using that. We don't know the implementation, but still we can go for that.
Okay.
Okay. Now this is a very simple topic. Just when we have this particular line. So here we have a method. So method will have method name. It will have return type. It will take some parameters. So signature means this is a function or method. So this function has its own name, its own, some parameters. Signature of a function means the name and its parameters or list of different types. Remember the word signature.
Okay.
And I will try to.
Argument and signature is the same, or is there difference?
No, argument is. Sir? This is argument. The name and argument together we can call a signature. Okay?
Okay.
So this is a small example for overloading. Now see here we have a
Which
class.
one is what is signature? Signature is the argument.
Name and this complete arguments. List of arguments.
The whole is called signature.
Yeah, when we say signature of function area, we can tell the name is area and the parameters are int L and int B, like that.
Okay.
So, okay. Here we have a class shape and it has a method area, and this area is taking an integer argument and it is returning after multiplying, like it is returning an integer value. So return type is int and the argument type is also int, and we have only one argument and the name of the method is area. And next we have another method. This method name is also same as this method. Okay, but the arguments, it has two arguments, int L and int B, and it is returning some integer value. So return type is int. And again another method whose return type is double, and it is taking a double value as parameter argument, and then it is returning something that is double. So here we can see that in the same class we are having three different methods, and these three methods are having the same name but different type of arguments. Okay, so when we declare methods in this way, this is known as method overloading. And I'll explain the main function to see how it works. Now I'm creating a object of type shape is equal to new shape, and then I'm trying to call the area after passing a value, an integer value 5. So when I pass area with a value 5, what it will do is it will go to the object, and it has three methods. First it will check the first method area int a, and what we passed an integer value 5. So here this method area is also taking a value, integer value, so it is a match. So this will be invoked and we will get the area return a into a. Okay, and the second case, s dot area of 7,2. Here we are passing two values, and now again it will go here and see the first method, but the first method can take only one parameter, so it's not a match, and then goes to next method. Here, yeah, we pass two values, two integer values. This is a matching, so this particular method will be invoked and we'll get the result. And again, next line, 18th line, again I'm calling s dot area of 10.0. So this is a double value. So now again it goes here, checking with the first method, but it is taking only integer type, so not match. So second, it is taking two different values and it is of integer type, so not a match. and going to the third method. Here it is taking a double value and it is a single value, and we passed a single double value. So this is a match. So this particular method will invoke and will get the output here. Let's run this. Java C overloading dot Java. So when we have different methods of same name and different type, which method to be invoked will depend on the arguments we pass. Java overloading. See the result, 25, because 5 square 25, x is 7 into 2, 14, x is 10.0 into 3.14, which gives 314.0. So this is overloading. Okay, just keep in mind this.
Yeah. Okay, fine.
My question was related to this. Now we have a class called.
Yeah, Arup sir will take that. I just gave this.
Got it.
Okay.
So actually, I think I clarified. Because, yeah, I got it. Actually, it's clarified.
Okay.
Anyway, yeah.
Now overloading is clear, right? The basic concept of overloading. Having different methods, same name,
Yes,
different type of parameter. Okay. And then next. So here, C3, C1 and C2, 3 different classes. And C3 is trying to extend from C1 and C2. So C1, here in C1 we have a function, a method called EF, public int EF. And in C2 also we have a method, public int EF. So both has methods with same signature, and C3 is extending from C1 and C2. Now, if it is possible, and if we create an object of type C3, and if we try to call EF, function F, then which function or which method will be invoked is a contradiction. Like this C3 will get both of this function if we try to extend from both C1 and C2. So if we don't have anything to distinguish between these two Fs, so that will create a confusion. Therefore, in Java, this type of inheritance is not supported. This is called as multiple inheritance. As for now, multiple inheritance is not supported in Java, but later when you learn interfaces and all, you will see how to implement this also. But now learn that by using this particular keyword extends, we can't extend from two different classes. So multiple inheritance is not supported in Java. So,
ma'am, is it supported in Python? This multiple inheritance?
I think yes. In C++ it's supported.
One thing, ma'am.
Yeah.
Here, go to the previous slide. Multiple. Here, suppose C1 and C2 do not have any common and same method. Then also this multiple inheritance is multiple extension is not possible.
No. In order to avoid that confusion.
C1 and C2 do not have any common methods.
Yeah, understood.
Then we can do, or
no, we can't do. It will compiler will not support.
Okay. It is not
so
possible.
Basically, ma'am, if we write C3 obj is equals to new C1, and then C3 obj, we can change the name. C3, let's say obj1 equal to new C2. So then can we access or no?
Then
we can't do C3 extend C1.
Inheritance. It's different.
You cannot.
You mean like this, right?
Not permissible.
C3 taking from C1 and no. Okay, next topic is Java class hierarchy. So yeah, we have already learned that that particular thing, manager class was inheriting from employee class, right? Using some keyword extends. So in Java, we have a universal superclass called object. So whenever we create any class, if we create employee class or animal class or any vehicle class, if we try to create any class, all these classes will implicitly extends from the class object. This object is this universal superclass, and object will also have some methods like toString, equals, finalize, etc. So every class we create will extend from object, and since every class is extending from object, whatever method that is available to object we can access in our class, our object. Okay, so you have already seen this particular. Okay, I will first discuss these two methods. In object class we have two method called equals and toString. What this equals method do is it will take two object and it will check whether they are equal in the sense equal in reference, pointer equality. It will check whether they point to the same memory location, not checking whether they are equal in values. It will check whether they are pointing to same memory location, pointer equality. So that is one method present in object class, and another method is toString. ToString is a method that will take an object and it will convert it into a string. I'll show this by an example. Now just remember that ToString will convert, it will take an object and it will convert it into a string. And see this particular x equal to y. We have seen this in week 2 practice questions. So if we have like, I'll show with one example. Yeah, here we have an array A. As you know, array is an object. So int A is equal to 10, 20. Now we are declaring another array B, and I am assigning this A directly into B. Now A will not get a different copy of A. What B will get is, B will not get a different copy of A. What B will get is, B will get the same reference. It will point to the same array. A and B will point to the same array. So as both of them point to the same array, the reference is same. So when we try to do this A equal to B, we will get it as true. And whenever this equal to double equal to operator is called, actually what happens in Java is this particular equal to will invoke the equals method which we saw in this slide, this particular method, and it will do the comparison operation and it will return whether it is true or false, whether the objects that we passed are equal or not. Is it okay?
Can you repeat again, please?
And object O.
Yeah.
Object O.
Object O.
This object O, how can we know that this object O is the same X and same Y?
Actually, since it is a method, see, this object, this is the
object
superclass.
Yeah, this is superclass. Yes.
Superclass. So first, see here. So this is a superclass. This superclass has the method equals, and that equals is taking an object O. Object O. So here, when we try to compare X and Y, usually when we have to invoke a method in a class, what we need an object, right? We need an object, and then x dot equals, we are comparing X with Y. So this will be the after effect. If we call X equal to Y, it will convert it into X dot equals of Y. So this X will be compared with Y. Okay.
Ma'am, My question is public boolean equals object O. The object O is the parameter for the equals.
Yes.
This parameter is required. How would we know that X and Y are from the object class, super object class?
X and Y are, sorry, I didn't get
Because
the
for Java objects X and Y,
yes.
X and Y, but in the method equals object O means object O is a parameter for the equals.
Okay.
That should be of the object class, and any object within the bracket should be of the super object class.
Yeah.
It is required, no ma'am, to run equals. Then
Yeah.
how would we know that X and Y are belong to the object class?
I told now every class will inherit from the object class. So if we write something like, see, so here if we write something like hierarchy, if you simply give extends object hierarchy. Actually it is implicitly extending from the class, but if we do like this also, we will see it will not throw any error, even though in this file we don't have any object class, right? But still if we try to extend object, nothing will, no error, sorry, there will be no any compilation error. So what I mean is every class is inheriting from object class. Okay. Yeah. And
okay.
Yeah.
It is inbuilt.
It is.
It is inbuilt object. Whether we write extends object or not, it will work.
It will. It is always extending.
Always all the class we write in the code is always extends the object class. Is it so?
Yes, correct. Because object is a superclass, universal superclass. Everything comes under object.
Then so how many methods are there? How many methods are there in the object class?
Many
so
are
that
there.
We can use that.
Yeah, like finalize, hash code, clone, wait. These are all some of the methods in object.
Okay.
And we are learning only this two, okay, equals and toString. And
okay.
So
in exam also only these two will be asked, equals and toString.
Whatever covered in lectures will be asked, like professor covered things.
Okay.
So in toString,
can you go back to that example that A is equal to B, some assignment you are doing now?
Yeah.
They are just hiding. First A value was 10 and 20. B is equal to A means like B value will also be 10 and 20, right?
Yes.
And then it is checking that whether A matches with B, and then
here it is not checking whether A and B has same value, okay? It is checking whether they are pointing to the same memory. Which means, which means A is having 10 and 20, right? And I am assigning B is equal to A, which means B will also point to the same array, this same array. So if I make any change like A of 1 is equal to 30, and if I try to access system.out.println B of 1, then it will also give what, 30 or 20? 30. Okay.
30.
Both A and B will point to the same memory location. Okay. So
and if you want to copy those array like from one to another variable, how will we do that?
We have some other methods like clone method and all. We will discuss later. Deep copying and all. It will come in next week, not next week, 6th or.
Okay, ma'am.
Okay.
My methods are not objects, right? No, only methods are not objects. No.
Methods come inside objects, right?
Okay, methods are not objects. Methods come inside the object, which methods operates on the objects. Is it so? No.
Methods operate on the objects, instance variables. We can tell that on the objects.
Okay.
Now, one more thing is overriding. We'll discuss that overriding also. So this is the same example of class employee and employee constructor, and here we have this particular method bonus, and again manager is extends from employee, and manager has another bonus. This is just to understand what is overriding. Okay, now don't confuse with dynamic dispatch. Here I try to create one object of employee and then manager M, normal manager M, and then trying to call e dot bonus and then again m dot bonus. So here we are providing the same salary to both employee and manager in order to see the difference. Okay, one more thing I left there is I told about the toString method in object, right? That toString method will give something like this after we execute. Overriding. Here see, in employee.bonus, when we called e.bonus, the bonus method of employee is called and we got the salary as salary into 0.1, that we got as 10,000 here. But in the case of m.bonus, we know that this manager will get all the variables and all the methods of the parent class employee. So all these variables, including this public double bonus method, will also be present in manager object. But manager object, we have already also declared one more. We have also defined one more method, bonus, which is of same name of the previous bonus and same signature, completely same signature, including the type of parameter. So now manager has two different bonus. We will feel like bonus method, manager has two different bonus methods, but what happens is the second method we write in manager, it will be in effect, which means whatever method we have redefined will be one comes in effect. So m.bonus will go and invoke this particular method and we'll get salary into 0.2. That's why we got it as 20,000. And the first method which we inherited from employee is now not available. It's hidden. This is overriding. Overriding means we are redefining a method which we inherited from the parent class in the subclass. Is it okay?
Yes, ma'am.
Okay.
Kubra?
Yes, sir.
Sorry. Yeah. Shall I complete my discussion because I'm having a class at 8?
Yes, sir. Completed. My part completed.
Yeah. Okay, you're done. Or otherwise, if you want, you can come back once again.
Okay, sir. Okay.
That will be fine, right?
Yeah.
Ma'am, will you share this slide also?
Yeah, it is actually present in supplementary materials.
Okay. Thank you.
Okay.
Sir, you will share the screen, right?
Yeah, I'll share the screen. So you can continue, no problem, like once I have done.
No, sir, it's actually the end. Like overriding is the last one.
Okay. Shall I share?
Yes, sir.
Okay. Okay, see, like there are more discussions there about this week. So there should be discussion on that modifiers, and there should be discussions on one more topic, right? Modifiers, and what is another one is there?
Subtyping versus inheritance.
Subtyping, yeah. But before I go into that, so I don't think I'll be able to cover everything today. So Saturday, maybe I'll start with the concepts. Then afterwards, we'll go for discussing the questions and all. So let me first discuss few basic things over here. Basic concepts rather. So this, my screen is visible, right?
Yes, ma'am.
Okay, okay. So let me write a very small code. Okay, so I have something, so I want to change this. Okay. Key, and I'll have so what you can see here, I have two classes, a class A, which is having function f. There is a class B, which extends A, right? Which is have a method called G. Okay, so I create the object of B. Using that, I'll be able to call the functions f and G, because since it is an inheritance, the implementation done by the parent class, the superclass, is available to the subclass also. So the implementation of f will be available to B also, right? So I'll say B is inheriting from A. I'll be saying B is inheriting from A, right? Now, whenever B is inheriting from A, it automatically becomes a subtype of A. It automatically becomes a subtype of A, because B will always have whatever A is having. Along with that, it can have something extra. So definitely, subtype is basically a superset of the features of the particular type, right? The subtype is a superset. So subtype having G as well as F, whereas the type, which is A, having only F. So B is a superset of A, right? Is it okay? It's clear?
Yes, sir.
Okay, so subclass will be automatically becomes a subtype, right? Because it will have whatever the parent is. Yeah. Hello.
Superset means superset means the B is having more functionalities than A. That is why we are telling
not
it.
Only more, B will have everything A is having along with something different, right? So that means B is a superset. So that means it's automatically a subtype, right? So that was the idea of subtype. So whenever we create a hierarchy in Java, class hierarchy, so that's basically the inheritance. So basically the hierarchy achieve, the hierarchy allow you to achieve both the things like inheritance as well as the subtyping. So both you get together. So inheritance means I'm getting the implementation from A, my superclass, and subtype B is holding whatever A is having, but it can hold more of the things. There was another alternative definition of a subtype. It say whenever I can use an object of A, I can also use an object of B. We want to see that. But before that, let us have an idea what this object creation does means, right? So what is exactly happening whenever I do this? So if you look at the memory, so this is the memory segment, right? So as you know, there are stack, there is heap, etc., etc. So normally, let us see. This is, say, this is your stack, right? This is your stack. which is moving down, and you are having some heap, right? So this is the area for heap. So let us draw it separately. So let me draw this is as the heap memory, and this is the content of the stack. So I'm drawing them separately to clarify the understanding, right? So suppose in my code, I'm having a code aobj equal to new of a. So what exactly happens? So I can actually write it into two steps also. I can write it as obj. Then next line I can write it as a obj equal to new a. Right. So these are basically the same thing. The moment you say a obj, obj is basically a reference variable which will be created within the stack. Now the second line, whenever I'm saying new a, a memory will be allocated from the heap, because this is a dynamic allocation. New is the operator which do a dynamic memory allocation. So what this memory will hold? This memory will hold all the instance variables which are there inside the class A. Right. Now what we'll have here, this obj will refer to this memory. Right. So this is what we'll have. Now let me do it in a different way. Okay. So let us have only one class. I'm having a variable, say it's a int a or int data, and using function this, I basically try to print the data. Right. So this is what I want to do. Say I also have a constructor. Right. So this constructor, suppose I'm having a parameterized constructor. So that's say d, so data equal to d. I can also have a all constructor which may assign this data with a 0. Any doubt about this code? So now I create a new object O1, right? Now for O1, I assign
Should
the
be
data.
new of A or something like that, right?
Sorry. Okay. Yeah, I missed it. Okay. So data equal to 10, right? Now, what exactly happen if I do this? Right? I want to explain this code. Okay. So as we have drawn, so we'll have a stack. We'll be having a heap. So heap normally we give a irregular structure because it's our dynamic allocations normally done from it. So now if you look at this code, so this O1 is a object, O1 is a reference variable which will be created within the stack. Now the moment you call the new, so a memory will be created. So this is the object of class A, which will hold the instance variable data. So inside this, you'll have a memory which is data. Now the moment you create the object, so you're basically calling your parameterized constructor. What it will do, it will initialize data to a 0. So what we'll have here, we'll have a 0. But on the next line, what I'm doing, I'm saying 1 dot data equal to 10. So where this 1 is pointing to, it's referring to this particular memory. So whenever I say O1 dot data, so it's basically access the data which belongs to this memory. And if I say 10, so that means this value will be changed and it will become 10. Right? Up to this, is it clear?
Go to the next slide, man. Next slide, sir. Sir, next slide.
Next slide.
No, yeah, here.
Huh?
The two constructors are there, na? A and A int D.
Yeah.
And the line number 6 and line number 3.
Yeah.
So whether these both constructors will work at a time or only one will work
Can you
initialization
tell
only?
me which one I'm calling here?
You're calling the first one.
Signature will tell
One
you,
with
no,
no
this is the
argument.
default constructor.
Yeah,
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 no argument on it.
yeah.
That's the point. Yeah.
Yeah.
So if I run
Yeah.
it, so what I'm printing? The data of 1. So data of 1 is, what is that?
10.
Why it is taking so much time? Yeah, 10. Okay. Okay. So let me do another thing, right? I write the constructor in a different way, right? So within my parameterized constructor, I pass the object of A itself. And here I make the data equal to obj.data. So let's see what happens. How do I call it? So I can have a O2, then I'll make it's a O1, right? If you look at this code carefully, O2 is again a reference variable of type A1. Now the moment I call new A, I'll get a memory, right? Which will have, so this is a A again. Here I'll have the data, right? Now I'm not calling the default constructor, rather I'm calling the constructor whose argument should be of what type?
A.
Object.
Class A.
Object.
Whose argument will be of type class A. So because O1 is of type class A, so which one will be called? This will be called, right? Now what is OBJ? Right. What is OBJ?
That's the object. O1.
OBJ is nothing but O1. Okay. So let us see what happens. This O2, where it is pointing to? O2 is pointing to this memory. Right?
Yeah, second memory location.
Now I'm saying this is nothing but O1. So I'm saying O1's data will be copied into my data. Right? So that means this will be copied into my data. So this will come here. Right? I'm saying, so if OBJ is O1, this is O1 I'm passing. This OBJ become 1. So O1's data will become my data, right?
How that value becomes O1, like when I'm writing O1, how does it refer
I'm
to
passing O1, no? So argument is O1.
Yes.
So OBJ will become what?
O1.
OBJ is what?
OBJ will become O1 now.
It is O1, obvious. So if I say obj.data, that's nothing but O1.data, right?
Yes.
So O1.data will become my data, right? If I don't write it anything, it's basically writing same as this dot data, like my data. This means the current object, obj.data. So who is the current object? See, the call is made on behalf of O2. So this refers to which object? O2. So yes, this refers to the current object. So current object here O2, because the call is made for O2. So that means the data of O1 will be copied to data of O2. Is it clear?
Yes.
Data is a variable. Data is a variable, no? Instance variable.
Yeah.
Data is an instance variable.
Println O2 dot data. So what will be the output?
10, 10.
It will be 10, 10. Right. Okay. So now if I change this data to 20, so what should be my output?
It will be 2010.
It will be 2010. Some sounds are coming. Can you check, anybody? Okay. Okay, so O1 dot data. See, in this line, whenever I'm doing O1 dot data, that means this is getting changed, it is getting 20, right? But it is not affected, right? It will remain the same because it is a separate memory. So that's why whenever I say O1 dot data, I'll read 20. Whenever I'll read O2 dot data, I'll read 10. Does it make sense? Hello?
Yes, sir.
Okay. So now let me change the code a bit. I'm deleting this line, these two lines for the time being. I write A, O2 equal to O1. Right. Then I say O1 equal to 20. Can you tell me, will my output will remain same or it will be different? Does it the same? Is it the same thing or is it something different?
I think it will become 20, sir, for both.
Yeah. So now, if I do this, you need to understand what will happen, right? So I take another memory, another picture for it. I have a stack. I have some memory. Okay, so here I'll have O1. O1 is already pointing to some memory, which is having this data, which is initially 10. Okay. So now question is, what will happen if I say this line, right? So first I create a O2. Next, you have seen here for O2, there is another memory allocated, right? But here, am I allocating any new memory for O2?
No.
Because I haven't used the new, right? Rather, I am saying it will refer to O1. So that means this will refer where O1 was referring to. So basically, they are pointing to the same memory, right?
So any changes in O1 will also reflect.
Yeah,
in
any
O2.
change in O1 will be reflected on O2. If it is changed on O2, then reflected on O1. So if I make it 20, so this is getting to be 20. That means O1 dot data also 20, O2 dot data also 20, right? Both are 20. If I run this is 20. So whenever
we
Cobra
get the
was
same output if we write O2 dot data equal to 20, right?
Yeah, we'll get exactly same output. Because you the concept is important here, right?
Unless until we create new, no memory
so the
location will
same
be
memory is
located.
changing, right? Yeah.
Okay.
So if I do this, the first step, it's basically we are copying the value. Afterwards, you'll come to know this is basically called deep copy. And this is basically I'm copying the reference. So this will called shallow copy. So these two terms will come to know afterwards. For the timing, just try to understand. First case, what we have done, we have created the memory separately. We have only copied the value of the data, right? But in the second case, I have copied the reference. Means I'm saying I'll refer to the same thing what you are referring. So if I do that, if I change in one object, that change will be reflected to another object also. Does it make sense?
Yes, sir.
Everyone, right?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So let me go for a little more detail. So I'm saving this code somewhere. So maybe we'll provide this code somewhere. Afterwards, if you want to follow the code. Yeah. Keeping it over here. Okay, I'll delete this. Okay, now I'm going to the scenario of inheritance. So I have a class A, right? So I'm not writing any access specifier over here. So let us assume everything is like a public. Println, I say it is from A. I'm calling the function f, and we have a class B which extends A, which will have void G system dot out dot println B G. Okay, public static void main. Oh, I have to create another class, right? Class main.
Yeah.
Okay. So let me create an object of B, obj of B equal to B, right? So if I do this, I can call obj B dot F, obj B dot G. So everyone has seen it, right? I don't think I have to explain this. Do anybody need explanation for this?
But the double colon means A double colon F.
That is just I'm printing.
Okay, okay.
It will be printed like this. If you just say it's a dot, it will be printed as a dot, whatever you want.
Okay, okay, okay.
This is basically a kind of technique we use in C++ for showing belongs to.
Okay, okay.
So it's just printing. Okay. Which is subtype? Which is the type? Which is the subtype?
B. B
is the
B is the
subtype.
subtype.
Okay. Now, the question is now, I can write A obj of A equal to new A, right? It's possible?
Yeah. Possible.
Now, obj dot A, can I call F?
Yes.
Yes, sir. You can.
I can call F. But can I call obj of G?
No.
No, no.
Sir.
No, because it is not the subtype.
Because
Yeah.
they're
No,
inheriting
just-
A, but A is not inheriting.
Yeah. Now go back to your first week. We told whenever you can use a object of a type, you can always use the object of subtype because it is more capable, right? So this is I'm using object of A, right? Can I substitute with the object of B? Because object of B is more capable. Object of B is more capable. So I say where I can use the object of A, I can also use the object of B. We had this definition of subtyping in the first week, right? So you can see,
Yes.
if I even do this, this code works. Even, interestingly, this code won't work. Why?
What did you tell?
The type is A.
1 minute, then I will show.
Okay.
If I do this, I get this. Now see, my object is a B-type object, right? So that means I should able to access G also, right? But if I try to access G, it's giving me the error. What is the reason?
Because we are defining A as a B type, B as a A type, and B has like
because new
overriding
B is referring to the
Okay. Go back to again the first week.
If you do something like if you typecast object A as B and then call G, it should work.
Yeah. But why it is not working? My question is.
Because it's referring to A. It's the type. Though
It is
see,
referring to B.
no, B is B will invoke the superclass. So it is the
B is the subtype, right?
B is the subtype. Yes.
Yeah. Okay, so go back to the week 1 again. So subtyping is all about the capability, right? It's all about the capability, and inheritance is all about the implementation. Have you read this?
Yeah.
Subtyping is all about the capabilities or interfaces, right? And
Yeah.
inheritance is all about implementation. Okay. What is the capability of type A? What is the capability of type A?
Function F of
F. Only F.
Method.
What is
Method
capability of type B?
F and G
F
both.
and G.
F and G both. See, if I want to call something on OBJ, which is of type A, F is under its capability, but G is under its capability or not?
No.
A don't
No.
have the capability, right? So this is
No.
subtyping, right? Getting all you read on the first week, all are true here, right? First thing, you can definitely substitute a object of A with the B. So a subtype object can always replace the supertype object, right? The first thing. But what about your capability? Your capability of your particular type of your reference, right? What is the capability of the reference OBJ? It is the capability of A. So if A having capability to call the method F, not the G, so that's why using F, using object A, I can call only F, not the G. Does it make sense now?
So in the memory diagram, OBJ A is pointing to the
I'll
memory
do
of
that.
B.
I'll do the memory diagram just now. I'll do. But that's. Can you correlate with the first week? That's the important question here. The
Yes, sir.
statement we have made on the first week, can you correlate it? Because you need to derive the things, right? From the first week, the second week will come. From the second week, third week will come. So you need to take your knowledge to the next week, right? Then the proper learning will happen. Okay.
Correct.
So if you are clear about this, let me go for the object diagram. Okay. Now there is a principle we called as a principle of method dispatch or principle of dynamic method dispatcher, which says a reference can refer to its own object or subclass object. Subclass or subtype object.
Yeah.
But never can refer to a superclass object. This is very, very important statement, but this statement comes from the knowledge of subtyping only. So subclass is a subtype, right? So we know always supertype can be replaced by the subtype, but subtype cannot be replaced by the supertype because subtype having more capabilities than the supertype. So that's how, if you have a class A which is inherited by a class V, right? Now if you have an object of A, so reference of type A, that can points to A, OBJ2 can refer to an object of B object of B. If I have a object of B, it's a reference of B that can refer to its own object, but can it refer to
No, no, we can't.
object A?
Fourth
No,
is not
not.
possible.
So
Fourth is not possible.
this is not possible, right? So our reference can point to its own object or child object, but never can refer to its parent object, right?
Correct.
So this is actually fulfilling the principle of subtyping only.
Sir, one quick clarification.
Yes.
This upward arrow from B to A. In this diagram, B is a B is a child class and A is a parent class, right?
Yeah.
Okay, so the upward arrow means the upward box is parent.
Upward box is the parent. Yeah.
Okay. And
This is arrow called as a generalization arrow.
Generalization arrow.
Why it is called a generalization?
Yeah.
See, I have animals, right? Now, if you say a bird is an animal. Mammal is an animal, or reptile is also an animal, right? So they are all subtype of animals. So they got something special. So animal is the generalization, whereas this bird, reptile, and mammals is a specialization.
Yeah.
So if you go upwards, that is the generalization. If you go downwards, then that is called as a specialization.
Correct. No, the doubt was happening because in general subjects we have been habituated, like the downward arrow, like from animal.
No, that's wrong. So that's object-oriented way. That's wrong.
Yeah, Ashish sir. Now one more doubt might be that I'm mixing some concept, because the moment the concept of subclass is clear to me, right, or subtype is clear to me, but the moment we are comparing it with subset, like in lecture professor has also used the term subset, right? So there I am getting some confusion. Say for example, if you can write it down, there is a set A having element 1, 2, 3, 4, 5. Set A, yeah, that curly braces 1, 2, 3, 4, 5, right? And now I am defining one more set B having only 1, 2. Now in this case, my B is a proper subset of A, and if B is also having 1, 2, 3, 4, then B will be the subset of A, right? With respect to set, is the understanding clear?
Yeah.
With set, it is, but
if B is a subset of
B is a proper subset of A. B is a proper subset of A, and say for example, if B is having 1, 2, 3, 4, then B will be the
if it is a proper subset, it has to have the thing, right?
Correct. This understanding is clear. Now let us talk about subtype. In subtype, my subtype is having more capability. Just now you also mentioned, like manager class. Every employee cannot be manager, right? But each manager is an employee. Then why we are calling manager as a why we are comparing it with subset? Because subset.
Yeah, I'm telling you your own example only.
Yeah.
If you say employee,
right?
Suppose employee having a method called as a say F.
Let us take name. Yeah, name.
That's salary.
Yeah, name salary. Yeah, name salary.
Okay, name and salary. Yeah,
name
salary and
right.
Name.
And now manager is having.
Manager will have
name, salary.
Name, salary.
And say for example, experience as a manager. Experience
salary
as a manager.
Or a department.
Yeah. Okay. Correct.
So which is subtype?
No, subtype manager is a subtype of employee, right?
Yeah.
But with respect to set notation, manager is a superset of employee. Manager is not a subset of employee. Am I right or wrong?
That is the logic, right? Manager is a
superset of employee. Manager cannot be a subset.
Manager is a superset of an employee.
Right.
So that means the manager is the subtype, right? Yes.
Okay, so here in case like superset is a subtype, right?
Manager, one minute. I'm getting confused now.
Manager is an employee.
I wrote it ulta.
Yeah, you wrote it ulta. Yeah, correct.
Yeah.
Employee is the superset of manager. Yeah, now it's what is the problem?
No. This is not the sign of superset. Sir, superset sign is ulta. Like the reverse.
No, I'm not saying superset. I'm saying manager is a sorry, employee is a subset of
correct.
manager.
Implies a subset of manager, right? But with respect to subclass, manager is a subclass of employee.
Yeah, so that same thing. No, this is subtype. So as per this.
See, okay, let me rephrase my sentence. Subset is not subtype. That is my statement. Am I wrong, right or wrong? Subtype is not
for
subset.
Java. It is true. Subset is the no.
Yeah.
Subset is a subtype. No, it's reverse.
Correct. It's reverse.
Superset is the subtype.
Correct. But many occasions, even professor is also using the drawing the parallel with subtype as sub.
No, it's okay, right? You just try to realize it. If
no, I got it. That's
way,
why I said.
This is superset, right?
Yeah.
This is also superset.
Got it. I got it, sir. Thank you. Yeah.
It's just reversing the thing.
Yeah. The name sub is being defined differently in Java. Is it so, no?
Yeah.
Here inspector and sub-inspector. Sub-inspector is having more capabilities than the inspector in Java. Is it so, no? Correct.
Yeah. Okay. So if this understanding is okay, this is very important. Okay. So let me ask.
So just a small doubt I have regarding this one. Is in this, when we create this object A object 1 and B object 1, so what that means actually, like this, it will refer to the same. For example, the first line A object 1 equal to new A.
I'll just show it. That's better to show it.
Yeah, please explain with help of diagram once.
Memory diagram, yeah.
Okay, so this is the last thing today. So maybe Saturday we'll start with this discussion, then we'll go for the questions. So O1, O2, O3, O4. So I'm having 4 objects, references. So also these are OBJ1, OBJ2. So let it be O1, O2, same thing, right? If I create an object of A, so this is object of A can be referred by this. Then object of B, so this is of type A, this is of type A, it's possible. Now this is of type A, this is of type B, this is of type B, it's possible, but this is not possible. So if you look at this is, but this is not possible.
I am trying to understand, like this one, when we say it is object of type A or object of type B, what does that mean actually? But here we can understand this
here whenever you are saying new of A, so you're getting an object of A.
Yes, that is clear.
So OBJ1 is pointing to object of A. Object, and this is pointing to object of B, OBJ2. Although it is type of A. OBJ2 type is A, but it is pointing to object of B. It is type of A, but pointing to object of B. Right?
No, that is clear, sir. But I am trying to understand, like the A, when we say object of A, means it is referring to this memory allocation of A. And when we say it is type B, that is also referring to memory allocation of A. And why we are doing different types here? What is that use of creating different types of this one, object A or object B?
I didn't get your question actually.
Am I not clear?
No.
Okay. Can you scroll up little, please? Scroll little up. Yeah, here. Like when we are saying A object 1 equal to new A and B object 1 equal to new A. So what is the difference between both? Why we are using?
Oh, you are saying why I want to create this and this.
The first one and fourth one, sir. Last
fourth one is not possible, right? Fourth one is not possible. I
Okay,
told.
not possible.
So we may
But
compare
in
between this
second
one
and third,
and this one.
can you explain?
Second and third, yeah. So this is the second one, right? This is the
And
second
third, sir?
scenario.
Second and third, yes.
You can see the capability, you can call only the F. Now, the moment I make it B, right? See, the capability will become, you can call both.
F and G. Yeah.
Because since your type is B, you get the capability of F as well as G. So depends on this type, your capability changes. If I make it A, you're having limited capability. You can call only F, right? But if I make B, I have capability to call both the things. Okay. So this is the thing I wanted to discuss. So I need to stop it now. So just I wanted to ask, I'll just stop the recording. Yeah, this streaming.